All right, welcome. So when doing a problem like this, you could see I have g of t equals -1/4 times t minus 2 squared times t plus 2 squared. And we want to determine the end behavior. And I did a couple of these problems, and I just want to kind of go through them again. When doing a problem like this, all right, first of all, we look at this and say, all right, if I was going to FOIL out t minus 2 squared, I know that's going to produce a perfect square trinomial, but that's going to produce a t squared, right? And it's really going to be t squared dot, 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 dot. If I was going to multiply this out, it's going to, again, my first term is going to be a t squared, dot, dot, dot. It's going to be a perfect square trinomial. Then, if I was to multiply these out, I know that by FOIL, I have to multiply those two, and that's going to produce my highest exponent. And remember, when determining end behavior, that's all we're concerned about is the highest exponent. So we still have this -1/4 here, so, and g of t. But you don't have to FOIL everything out to determine end behavior. All right, so I'm trying to save you some time here. So to determine end behavior, I see that this is positive, and my leading coefficient is negative. Therefore, my graph is going to fall left and fall right for its end behavior. Now, to find the zeros, I now take my function and set it equal to 0, but I don't need to have everything multiplied out, because actually having it in as written as its factors has already really done most of the work for me. Because now I already have it as a product equal to 0. Now I can just say, all right, well, I have t minus 2 squared equals 0, and I have t plus 2. Yeah, t plus 2 equals 0 squared. Now you might say, well, what happened to the -1/4? Well, the -1/4 is just a multiplier. And what I did, but I didn't say anything for, is I divided it out on both sides. All right, and when you divide it out by both sides, it's really not affecting your problem. It's not another product you can set equal to 0 because it doesn't have a value of t, and we're just trying to find the values of our t. So now, by using our square root method, I'll take the square root of both sides, and I get t minus 2 equals 0. Here I have t plus 2 equals 0. So therefore, my zeros are going to be t plus 2 and t minus 2, or t equals -2. So now, when looking at the multiplicity, we need to go back to the factors and look at the degree of our factors. And here you can see that both of these factors have a exponent of 2. So therefore, the multiplicity of both of these zeros is going to be an even multiplicity of 2. Thanks.